One has an oil leak.
So today on our bench is a set of 912 cylinder heads. These were sent in just as a set of bare heads for us to inspect and possibly service. So we've given them a wash. Then when they came in, they were pretty dirty, as most of these things usually are. So I've just got all the big chunks off, enough to be able to get a chance to kind of look and see what we might have to do. A couple of things, a quick measurement down from here shows that the heads have been fly cut once, so the boss size here is pretty good. I did an overall cylinder head measurement, and the distance from here to the valve cover area is in as new condition, so this part here has not been fly cut. Valves are original valves, ATEs, that you can't buy anymore. And taking a quick look at it, we have exhaust guide first. And this is kind of all over the place. I could pretty much feel it when I pulled it apart. There was nothing left of the guide. See it flapping about everywhere. Put your finger over the back, no suction generated. Now I just buffed off some of the carbon, as this is an unclean valve. And you can see not in very good shape. But this valve has actually hammered into the seat enough to where I can physically see the groove of the seat. So for me to cut this, I would have to cut away so much of the valve. It is not worth resurfacing. On the plus side, the valve seat heights don't look too bad. Normally these, you'll see them and it's hard with all the carbon still on it. You'll see these will actually countersink down into the seat more when they've been overcut. This actually looks to be pretty good, same with the intake ones. It's hard to know until we're 100% done and we get some installed heights, but all in all, doesn't look too bad. One of the last things I'm going to do is just use a surface comparator. And I don't care what the number is because I know what my depth is. What I'm looking for is just concentric readings that we're still fairly flat within 0.05, and looking at it all, we're pretty much there. We're like 1.41, 1.42. Same on the other side, 1.43. And all I'm doing is looking that these surfaces are parallel to each other, so that when it's bolted up, both cylinders are at the same height. So I think we have enough. With the one head apart, I'll have to pull the other head apart, but I would assume that it's going to be in pretty much the same condition. And until we actually start doing the work and getting into it, you never know exactly how much it's going to cost, but I should be able to put together an estimate and send it off to our customer. So today in the shop, we're working on a set of 912 heads. These ones were sent in to us. I've already disassembled the valves out of it. Exhaust guides are really badly worn, which is fairly normal on these, just like any air-cooled engine. The heads themselves don't look too bad. Quick overall measurement shows some minimal amount of machining. There's still some stamping here. This clearance right here is still fairly big, which is a good indicator. If these have been fly cut a bunch of times, you'll see this will be worn down to almost nothing. So we're gonna get this one into the blast cabinet. I've got one on my mill deck right now. The customer expressed a concern with the deck heights here for the cylinder sealing surface not being concentric, and a quick measurement with a vernier caliper showed some irregularities. So I had just two barrels sitting on it, and what I'm looking for on my straight edge is if I have any rocking or movement, and this one's actually feels pretty good. I need to get my dial gauge on it and do a true run out on that sealing surface just to make sure when you bolt it up, both barrels are compressed evenly and get a good head seal. So we're moving forward. Okay, so we're going to machine the tops off our guides just like we do on a 911 head. Now we're ready to punch out the intakes. I've got to set up on an angle to machine the tops off the exhausts. So same as we do on the 911s, I've got all my valve guides and I've measured my guide diameters that I start with. And inside ball mic. So this one we've got 14.024 of a millimeter. And we're looking for about 0.05 of an interference. So the best one is going to be right here, 14.075. Will fit nicely into there. It'll give me about 0.051 of interference. So I'm just going to go down, do the same process, measure each one. If I need to pull more guides and measure, if I don't have the right size, I'll do that accordingly. And we'll just get the guides installed and move on. So I've already set up my cutter. This is the first one that I cut and just patterned it up. So a nice pattern all the way. And now it's got a bunch of metal shavings in it, so it looks furry. But the pattern is right in the middle of the valve face, sealing face. Nice solid pattern all the way around the seat. And we just cut the second seat there. And ready to move on.
Careful.
What am I being careful of?
Shoulder hitting the moving.
One of the next things I'm going to do is repair the exhaust stud thread here, the top probably 5 millimeters of thread is just being pulled out of it. So we're going to go ahead and put a time serve in there. I've already set the head up on an angle plate and intrude my gasket area so I know my time set is going to be straight. Okay, so we're just setting up to do a very light chamfer cut. This particular customer is going to be using an 86 millimeter barrel, and all we're doing is we're just taking that kind of sharp edge out here. So you can see here it's a pretty abrupt finish. It's still not bad. If you were using an 82.5 millimeter barrel, it would be fine. And all we're doing is just putting a very light chamfer cut. It's approximately 0.1 of a millimeter thick. And just to make that roll up in, because a little bit of this sealing surface right here is going to be exposed to the chamber itself with an 86 millimeter barrel. So we can see we've got our slight chamfer there. It's just cleaned up that roughness. Hasn't taken off a lot of material. It's just smoothed it out quite a bit. So I just lapped in our valve. This is the exhaust valve. You can see the seat right in the middle of our face, which is where we want to see it. So part of doing our final valve in is doing any final homework. I want to make sure my valves are moving nice and free. A little bit of a pop with no oil. Just making sure it's pulling a vacuum. Should have some rock in all directions, which it does. So it's part of, just because we've done all that machine work doesn't mean there's not final checking. I also have my hone here, final hone work. I've given them a rough hone to begin with and just final fitting of the valve to make sure everything's moving freely, and we're lapping these ones onto the seat. Okay, so I've got one last valve to install. These are slightly different than the 911 heads. The installed height is going to be slightly different. These I find it's easier to measure with my vernier calipers. So I've just got the valve installed with the retainer on, and the thickness on the retainer is 2 millimeters. So what I'm going to do is measure down to the seat, touch the top of the retainer. We've got 45.5, so we're going to minus 2 millimeters for the retainer, which leaves us at 43.5. Then the installed height for an intake on one of these is 41 millimeters, so that means I need 2.5 millimeters worth of shims. On the 4-cylinder engines, they come with one thick shim, which is 1.5 millimeters, and then we've got 2 half millimeter shims. So these together should give us 2.5, 2.56. And then we want the thick shim facing the spring, because the 912 356 heads don't have a bottom retainer for the valve spring. So we're going to go ahead, pop our pieces out. Then 912 heads run a single valve stem seal on the intake only. You'll see in here on the exhaust side, there is no valve stem seal. 356 engines did not run the valve stem seal, though you can add them if you like. The way these sit in the motor like so, the valves are always right up at the top. They want a little bit more lubrication on the exhaust side, but it's not really a big deal whether or not you do run a valve stem seal. You will get a little bit more smoke if you don't. So we're just going to put our shim pack in first. So we have our shims, thick shim on top, valve stem seal presses down. Lubricate our valve stem seal. I usually like to try and work some of this stuff in. You'll also notice that it'll have a big vacuum on it. The other thing that's different with valve springs is you'll notice that these are a constant spring, unlike a 911 spring that has coils. It's a variable rate spring, so the more it's compressed, the more pressure it applies. These ones can go in either way, doesn't matter. Okay, last thing, I'm just going to seat these. Okay, so that's valves all assembled into the head. We're going to move these over to the CC chamber next, put a spark plug in each cylinder, and we're going to CC and record all of our chamber measurements. The original heads were marked. This 62 refers to 62 cc's. We're going to see where we're at, and if we need to, we can just X this out and remark it. Also, if heads are being machined, often you won't see these. These are a really nice set of 912 heads. One of the big giveaways is this large boss left here. Porsche gives a dimension from new measured from this face to the ceiling face is 9.5 millimeters and is worn out at 10 millimeters. So what a lot of machine shops took that as is, oh, if we just machine this surface off and machine this back down to 9.5 millimeters, then the head's back in spec. Well, that's actually not true. That dimension from this boss to the ceiling surface was given to maintain compression ratio. So often on older heads, these are all old now, you'll see this is, I've seen it machined basically where this boss is completely gone and all you see is the fin. And I've pulled these engines apart in excess of 13.5 to 1 compression because they've had so much taken off the head, it moves everything down. Your rockers are out of adjustments, push rods become too long. It's really something that used to be a big problem. Now there's a couple of companies making aftermarket head castings. We haven't had a chance to use them. Wilhoit is one of them. Guy's been around for a long time. Was doing 4-cylinder engines before they were popular. But there is some options out there. But these ones are all done. Everything's set up. Came up really nice. Everything machined up. We had a couple of thread repairs in this particular head. Had a time cert in here. The other head's over on the bench. It's already reassembled. So we'll do our final chamber volume measurements and they'll be ready to go back to their owner. This also gives me a chance to check my valve seals. Make sure I have no brake clean inside the chamber. Just gonna clean off our assembly oil here. We have right on 62 cc's on this chamber. So because we didn't have to machine, we did add a slight chamfer. We took off the edge here because this particular customer is going to be using an 86mm barrel. So we gave these a very slight 30-degree chamfer, which really made that edge roll in nice, no sharp edges. But we didn't have to machine this surface down. We checked it with barrel height, so we have 2 barrels. Make sure that we were within our plus minus 0.05 of a millimeter, which we were. The 62 cc stamped on the head is going to stay current for this head. We'll set up the other one and measure it as well. .5 cc's. So this one's also marked 62, and I would be fine to leave that as a valid number. Right on 62. So all of these chambers are right on 62 cc's. Maybe a point difference in it, or a half cc is the most difference. Otherwise everything's coming up nice and even the way it should do.